Hello, 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 ladies and gentlemen, and welcome back, welcome back. We're looking at question 4 on the 2014 MMC Manitoba Mathematical Competition. So, A part, the average value of 2013 consecutive integers is 2014. What is the smallest of these integers? Okay. So we've got consecutive integers, and so while we don't know what they are, we do know how they look. And we want the smallest. So let's say something like, let x be the smallest. Okay. Our numbers look like x plus 1, because they're consecutive, right? So x plus 1, the next one's x plus 2. I've got 3 of them already. For the fourth one, if I just had 4 of them, we'd go up to x plus 3. We want 2013 of them, so we'll go up to x plus 2012. Now, the average of these is what we're talking about. So how do we average things? Well, we add them all up, divide by how many there are, and we were told that that's 2014. Okay. So we can do a couple things. One, I don't like fractions, so we could multiply on this side to rearrange some things. We can also clean up on top. There's going to be 2013 x's. And then it's just going to be the sum of the numbers 1 plus 2 all the way up to 2012. Okay? And all that will be over 2013. Now, the reason I'm not getting rid of the fraction right now is because multiplying 2014 times 2013, while doable, I don't think it's going to be necessary. It's not, because we've got the 2013 here, so that just becomes 1 plus, and then, well, there's a formula for this. These are called triangular numbers, and in general, if I have 1 plus 2 plus 3 all the way up to k, the formula for this is k times k plus 1 all over 2. So really, this is 2012 times 2012 plus 1, but that's 2013 all over 2 over 2013. And sorry, this isn't 2013, it's 2013 times x. So we'll be left with an x here. So the x plus, and now these 2013s cancel. 2012 over 2 is 1006. So now I rearrange and solve for x. X is 2014 minus 1006. Difference of 8 there and a 1000 here. So x is 1008. Okay. So there we go. Not that bad. You did have to know the triangular number formula or be able to figure it out quickly on the fly. It's a nice little formula. I find it pops up a lot on contests, so it's one of the ones to just have in your back pocket. And if you're looking to find out more about them, I am going to move on and do a B part. But I will say, triangular numbers, that's the sort of thing you should be searching online for if you want more information about those. Okay, B part. What does B part have for us? Let A1 equal 2. Let A2 be 2 times A1, so 4. Let A3 be 2 times A2, so 2 times 4 is 8. Looks like we're just doing powers of 2. But they are trying to hide that from us. So for n greater than 1, an is just 2, an minus 1. Find and simplify the value of the 2014th root, the product of the first 2014 of these, times the square root of 2. Okay. So first observation, an is just 2 to the n. Okay. We can even prove this. A1 is 2, which is 2 to the 1. Now assume the formula is true for an. An plus 1 is 2 times an. So that's 2 times 2 to the n. It's really 2 to the 1 times 2 to the n. And how do we multiply things with the same base? We add the exponents. So that's a very quick proof by induction. You could probably write it out more, but I don't think anyone is really looking for that. I would almost be tempted to say clearly an is 2 to the n. What are they trying to pull, trying to hide that on us? Alright, so now that we know that, we are asked to evaluate the expression. Now, for some reason, there's a square root of 2 at the end here. Yeah, the 2014th root of 2 to the 1 is 2 to the 2, 2 to the 2013, 2 to the 2014. But again, if they have the same base and we're multiplying them, we just add. So this is really 2 to the 1 plus 2 plus 3 plus all the way up to 2014. And let's not forget the root 2. I'm going to change these square root signs into fractions. So the kth root of something is really just x to the 1 over k. So this square root of 2 is 2 to the 1/2. This 2014th root is the whole expression to the 1 over 2014. So this is 2 to the, and now I have this sum here. So 2014 times 2015 over 2 to the 1 over 2014 times 2 to the 1/2. Well, how do we deal with things when we got an exponent raised to another exponent? Why, we can bring them in and multiply, and that's going to cause this 2014 to cancel with this out here. So we'll be left with 2 to the 2015 over 2 times 2 to the 1 over 2, and those add together to be 2 to the 2016 over 2, which is 2 to the 1008. Okay, and that's really the most simplified I can make this. I can't write that number out. No one can. So we'll say that that is our answer. 2 to the 1008. We had to understand the pattern in the sequence. We once again needed to know the sum of the first k natural numbers formula. We also needed to understand a number of exponent laws and how square roots and nth roots relate to exponents, or how they can be translated into exponents. But not so bad. I kind of like this question, both A and B parts, and I'm eager to see what's in store for question number 5. And if you are, then I'll see you there as well.